From heating food from the oven to keeping food cold for many days, aluminium foil is a popular kitchen utility that is used by the entire world. But have you ever wondered where it was first used and how this is made? Hey guys, welcome back to the channel How It's Made. In this video today, we take an inside look into how aluminium foil is made and how aluminium foil came into existence. But before jumping into the video, if you're new here, please consider subscribing to our channel. Also hit the bell icon to get a notification whenever we upload a video. That said, let's begin. A short history of aluminium. But do you know how aluminium foil was born? The popularity of aluminium foil rose like a rocket because of its many applications that are indeed life-saving. One of the prominent being that the raw materials necessary for its manufacture are plentiful. Aluminium foil is inexpensive, durable, non-toxic, and grease-proof. In addition, it prevents chemical attacks and delivers excellent electrical and non-magnetic shielding. But to trace this life-saving foil, we need to go back in time to 1807 in ancient Egypt. Back in the year of 1807, aluminium was used by many Egyptians and commonly known as alumina. These alumina compounds, or as known as aluminium, were used to prepare healing medicines in Egypt. Moving forward to the 18th century, scientists discovered that these compounds contain a significant amount of metals in them. And in 1807, the English chemist Sir Humphrey Davy attempted to isolate it, but sadly his endeavors failed. Davy confirmed that alumina had a metallic base, which he initially called aluminium. Fast forwarding to 1854, Henry Saint Clair de Ville, a French scientist, refined Waller's invented technique to create aluminium lumps as big as marbles. De Ville's method supplied a foundation for the modern aluminium industry, and the first aluminium bars made were displayed in 1857 at the Paris Exposition. Thanks to De Ville, to this day his methods are used. Later on, when the worlds were at war, the aluminium demand skyrocketed like never before. During World Wars I and II, most other industrialized countries began to create their own aluminium for supporting their own needs. In 1903, France became the first nation to produce foil from purified aluminium. America followed suit a decade later, its first use of the new product being leg bands to identify racing pigeons. Aluminium foil was soon utilized for containers and packaging, and World War II accelerated this trend, inducting aluminium foil as a major packaging material. Until World War II, Alcoa remained the sole American factory for this purified aluminium, but now there are 7 major producers of aluminium foil located in the United States. How it's made? But how are these thin sheets made from such a big piece of aluminium? The manufacture of aluminium foils begins with the repeated thinning out of a large block of aluminium. The process starts by melting ingots of 100% pure aluminium in a natural gas furnace, these ingots called pigs. These are essential in alloys with zinc, titanium, and silica, and this takes 3 to 8 hours to melt 27,000 kilos of aluminium in this remelting furnace, which operates at high flames of 750 degrees centigrade. The fusion temperature of aluminium is 660 degrees centigrade, which is enough to 10 Rolls Royces. Next, a portion of aluminium is poured into a small mold to make a sample that is solidifying in just seconds. The sample allows the workers for testing to verify the content of this prepared alloy. After inspecting and getting a green signal, next, a trough is used. This trough is used to transfer the aluminium from the remelting furnace to the tapping well. Molten aluminium runs in a movable trough located above the tapping wall. At this stage, all impurities that are present are filtered out in special receptacles, and then the molds are cooled with water to accelerate the solidification of the molten aluminium ingots, now unmolded, and are ready for milling. Each ingot is massive, measuring 4.4 meters in length, 1.4 meters in width, and is 45 centimeters thick and weighs a stunning 70,500 kilos, which is equivalent to a medium-sized yacht. Because of this massive weight, it has to be handled by overhead cranes and placed on special plates. After overheating by the cranes, further a crest machine is used. This crest removing machine removes 3 millimeters of the ingot's thickness. Impurities are eliminated to achieve a perfectly smooth finish. All traces of liquid used to cool the decrusting knives have to be eliminated. The further process in the thinning of the ingot begins. The aluminium block is crushed further by the hot mill rollers. Temperatures inside the rollers are between 455 and 540 degrees centigrade, and pressure on the ingot is continually verified by a professional technician. If the temperature exceeds, then it's lowered by the technician and then adjusts the pressure. The heat is so high that the ingot risks sticking to the mill's roller. To prevent this from happening, everything is cooled with a liquid that is 95% water and 5% oil. This helps eliminate the roller to become sticky and sends it further. Further, starting from a thickness of 45 centimeters, the ingot becomes increasingly thinner. With each pass through, depending on requirements, the ingot will go through the machine between 12 and 16 times. The ingot, now measuring 7 centimeters in thickness, has to get down to just half a centimeter. After this stage, the ingot is 5 centimeters thick and measures a little over 9 meters in length. Then a conveyor transports the plate further for its milling stages. The ingot has now become a 5 mm thick sheet. It is sufficiently thin to proceed to spooling, where it spools onto itself before being sent into a cold rolling mill, where its thickness will be reduced still further. The aluminium sheet becomes very thin after the spooling process and risks being broken by the tension needed for cold rolling, so the sheet is doubled to avoid this breakage. One final reduction in the mill and the sheet will have the thickness required by a customer. A liquid coolant is used to prevent the foil from sticking to the rollers, since the edges of the foil sheet are lightly damaged and crinkled. A knife removes a 1 centimeter thin strip. Finally, the roll is cut to the desired width, and one huge ingot has produced foil measuring 12.7 kilometers in length. This now has turned into aluminium foil and is ready to fill the shelves of the shops. But have you ever wondered why one side of the aluminium foil is shiny and the other one is dull? This is not any secret technique, but merely a result of the process of fabricating aluminium foil, leading to the different builds of the two sides. One side is shiny and the other one is dull or matte after producing. The technique of producing aluminium foil implicates rolling aluminium slabs cast from molten aluminium in a rolling mill to get the desired consistency of the foil. It is due to this process, known as milling, that results in the difference between the two sides. During this process, heat and tension are used to lengthen the foil and give it the desired shape and size. To avoid damaging the foil, 2 layers of foil are squeezed together and milled at the same time. After the process of milling, the 2 layers are divided and then ready to use. The side that was in contact with another layer evolves the dull side, while the side that was milled without being in contact with the other coating becomes the shiny side. It is purely due to the existing procedures of making aluminium foil that it possesses a shiny side and a dull side. Here are some unique facts about aluminium foil. Number 1. Before aluminium was cheap and readily available, during the ending of the 19th and early 20th centuries, a type of thin foil used commercially was actually made of tin. Because of the rise of this foil today, many call aluminium foil this name. Number 2. More than just packaging, aluminium can be used to polish silver. After lining a deep pan with foil, cover it with cold water and add a couple of teaspoons of salt and your silverware. Chemistry, magic, will remove the tarnish. A similar process can be used to clean jewelry, except exchange the cold water for hot and the salt for a tablespoon of laundry detergent. Likewise, a sheet of aluminium foil underneath freshly polished silverware will deter tarnishing. Number 3. Scissors can be sharpened by cutting through several layers of aluminium foil a few times. Because it's a natural moisture repellent, in the gym, wool socks are the best choice. Wool was once worth as much as gold. The ransom for the release of King Richard I, the Lionheart, captured on his way back from the Third Crusade, was also paid in the highly valued English wool. That's it guys, let us know if you found this video informative in the comment section down below. Also, if you enjoyed the video, give it a thumbs up and share it with your friends. Don't forget to subscribe to our channel for more informative videos. See you in the next one.